we didn't quite finish up 1.4, so I want to take a look at that now. And I also want to take a look at a couple of the problems that people have emailed me about. Um, you had almost everything that you needed to do the assignment, but there were a couple problems. One that was a couple that were very strange, that used a symbol that you may or may not have seen before. Maybe you checked back in the book because they did talk about this in the section, but this is something called the greatest integer function. Has anybody seen this before? All right then, okay. This is a weird function and it's just used as an example. There are actual real life reasons why you'd want to have a greatest integer function. So this is the way it works. The notation that we use for this is either kind of a double square bracket or sometimes you'll just see a single square bracket. It depends on the textbook. This particular textbook uses the double square bracket to indicate the greatest integer function. And here's how it works. When you plug a number in this, it's basically asking a question, just like most functions are asking a question. So when we do this function, it's asking you to find the square root, okay? If I do this function, it's asking you to figure out what the absolute value of the number that we plug in there is. Okay, this question's a little bit strange. When you plug a number in, it's asking you to find the biggest integer. Okay, and remember we had that on the last test. Integers are? Wow, very good, Hop. Would you say that louder? Negative and positive whole numbers including 0. Okay? So when we plug a number in here, it wants the biggest integer that's not bigger than whatever number we plugged in. So the biggest integer, 0 is definitely bigger than all the negatives, and it's equal to 0. So the greatest integer for 0 is 0. What if I do 0.1? What is the biggest integer that's not bigger than 0.1? Yeah, all the negatives are smaller than that. Okay, 0 is the biggest one of all the integers that are less than 0.1. Okay, and what if we do 0.5? Also 0. What if I do 0.99999? What if I do a whole bunch of 9s? What's the biggest integer that's not bigger than 0.9? Okay, that's also going to be 0. What happens the second I plug in a 1? What's the biggest integer that's not bigger than 1? 1. Okay. And same thing for 1.5, it's going to be 1. And 1.95, it's going to be 1. And what happens the second I get to 2? I get 2. Okay? So let's come down here and let's graph those. What happens for this is every time we plug in a number in between 0 and 0.999, just a little bit less than 1, we always get out a 0. Okay? And I've got a closed endpoint on this one, and then I have an open endpoint right here. Because the second I plug in a 1, what's the new function value? What was the function value when we plugged in a 1? It was 1. So we come up here and we've got a point right there. And what happens everywhere in between 1 and 2? It's always 1. And then the second we get to 2, it jumps up here to 2. And it just continues on in this fashion. Okay? So a lot of times we'll call this a step function for good reason, because it looks like steps. Okay, and for some reason this part messes people up. What if I plugged in a negative 0.5? So let's do this one right here. Yeah. It is negative 1. Okay, so a lot of people will think, gosh, it's got to be 0. It's not. Think about the way the numbers are ordered. Okay. If I plug in a negative 0.5 is right here. This is 0 and this is negative 1. So negative 0.5 is right here. All of the integers that are less than that are on the left side. So the greatest integer for negative 0.5 is negative 1. The greatest integer for negative 0.01 is negative 1. The greatest integer for negative 0.99 is negative 1. What is it for negative 1? Still negative 1. And the minute I go past that, so the minute I get to here, like negative 1.5, then what's the greatest integer? Negative 2. Now, this should make us feel better when we graph this, because everything in between negative 1 and 0, the greatest integer is negative 1. So it follows this same pattern. And then the second I get to negative 1, the second I get past negative 1, it goes like this. Follows that same stair-step pattern, okay? So that's called the greatest integer function. Any questions? Okay, you had a problem like that. And then I had a couple people send me emails about these questions, and I was fully expecting these. Okay, we ready to go on? Okay, take a look at these problems right here. Recognize those? What's this little symbol right here? Okay, not a huge deal, okay, in this particular class. Okay, but if you're going to go on and you're going to do something like this, toward the end of first semester calculus and in a whole bunch of second semester calculus, you would want to be able to figure out computations like this or figure out expressions like this. All this asks for is it's asking very simply, what is the height of the rectangle? In other words, how far is it from the top of this rectangle down to the bottom of this rectangle? Okay? Now, I'm going to do something similar to what we did yesterday, and that's this. I'm going to take this rectangle and I'm going to draw it over here. I'm just going to draw a little bit bigger version of that. Okay? And I'm going to represent the height right there. So if I knew this was 2 and I knew the top of it was 3, how tall would it be? If the bottom of the rectangle was at 2 and the top of the rectangle was at 3, how tall would that little rectangle be? It'd be 1, right? That's pretty easy, right? Okay. What if this was at, let's say the height was at 2.5. How tall would it be? It'd be 0.5, right? No mystery here. That's pretty easy for everybody, isn't it? Any questions? Okay, well, think about what we talked about the first week of this class. Okay, if you can't figure something out, we don't want to throw our hands in the air and say, you know, I have no clue how to do this. One thing that you can do is come up with a numeric example. So these values right here for the top of the rectangle, in fact, right here, it looks like it's pretty close to 3 at this particular location where they've drawn it. So let's put a number in there just to kind of take a guess. So if we put a number in there like 3, everybody said, well, the height of the rectangle would be the difference between 3 and 2, so that would be a height of 1. Okay, but this isn't right at 3. In fact, the reason they put an X here is we could slide this rectangle anywhere we want here, and we could put that rectangle over here, or we could put it over here, or we could put it right in the middle. What they want is an expression for the height of the rectangle in terms of X, as a function of X. So we certainly can't stick with numbers. But in both of these cases, in order to figure out the height, I took the top of the rectangle and I subtracted the bottom. So I did top minus bottom. That would tell me how tall it is, right? Well, is the bottom always at 2? Yes, it is. The bottom of this rectangle, no matter where I drew it in this little shaded area, would always be at 2. It would always be at that horizontal line. How do I figure out where the top is? How do I figure out whether I'm here or here or here or here? How do I figure out how tall that point is? Noah? Plug in the y equation, okay? Doesn't that y represent this little parabola right here? Okay, so the function that represents the top is this right here. That's the top, and this is the bottom. Now think about that for just a second. If the top is this function, and the bottom is this function, and we figured out using numbers that I did the top minus the bottom, how do you think we'd figure out what the height is? Literally just take the top and subtract the bottom. So the height is going to be negative x squared plus 4x minus 1 minus, what's the bottom? 2. Would I leave it that way? No, I wouldn't. Okay, I'd want to simplify it, but notice what we've got here. I've got negative x squared plus 4x minus 3. Is that a function of x? Yes, it is. Okay? Any questions? Okay, take a look at 107. What's the top here? Top is, I heard it over here. What is it? Y equals 3. Okay. What's the bottom? Y equals 4x minus x squared. Okay. So if I did top minus bottom, I'd do 3 minus this stuff here. You'd have to be a little bit careful because you'd have to put the 4x minus x squared in parentheses. Very good. Very good. Okay? Guaranteed sometime in the next 2 years, nearly everybody in here is going to